Hello, this is Interact presentation number 4, the elephant toothpaste experiment for General Chemistry 2 via Doane University. The setup. The setup for this experiment includes a mixture of hydrogen peroxide, dish soap, and red food coloring, which is the photograph on the left. All these products were over-the-counter Walmart products, so it's normal hydrogen peroxide, Ajax dish soap, and Hill Country Fair red food coloring. The second part of the experiment is a mixture of simple warm water, normal warm tap water, and yeast, also purchased from Walmart. And the experiment involves combining the warm water yeast mixture into the hydrogen peroxide combination. We will then observe the reaction. Please note the reaction once it is mixed. You'll notice with this reaction, once everything is mixed, the foam immediately begins to form, and that is the reaction we would expect in this type of experiment. Now, what is happening at the chemical level? First off, it is a decomposition reaction. Specifically, it is the decomposition of the hydrogen peroxide. Therefore, the yeast and warm water is your chemical catalyst. So what naturally happens with this reaction is it normally would take a considerable amount of time, almost so slow that it could not be measured. Hence, a type of chemical catalyst is needed. This is your yeast and warm water. Foam also forms with the water. The water and oxygen forms, creating the foam that you witnessed in the experiment in the previous slide. And the speed of your reaction depends on the concentration of the hydrogen peroxide. The higher the concentration, the more the foam would be produced. The hydrogen peroxide used in this experiment was simple over-the-counter, so the concentration was not very high. Now, if you were to obtain your hydrogen peroxide from a chemical plant or a special chemical supplier, if you had the license or credentials, you could probably get a higher concentration and you would see a much more explosive result. As I mentioned earlier, under normal conditions, this reaction would occur slowly, and therefore a catalyst is often added or needed. This is true of most chemical reactions, as a lot of our chemical reactions do occur at a slower rate, and our body has natural catalysts in place to speed up the process of chemical reactions. One of the most common being water. And in this experiment, for example, we have water and yeast that forms. Now, this type of reaction is an exothermic reaction. Therefore, energy is released, usually in the form of heat. We know this because the foam that is released, if you were to actually touch it, is warm to the touch, indicating heat. And compared to an endothermic reaction, which removes heat or takes it in, sucks it up, this particular reaction, as I said before, is a decomposition, so the breakdown of the hydrogen peroxide via yeast and warm water, leading to the formation of foam, which contains water and oxygen. This type of reaction was sped up with a chemical catalyst, and the end result is the exothermic reaction that you would expect to see in this type of setup.